My name's Dave Wilhelm. I'm a professor at Wake Technical Community College in Raleigh, North Carolina. This break-even analysis 2 video is to help my students in various business classes at Wake Tech. Compared to the break-even 1 video, this has more of an emphasis on how to determine the break-even quantities where there are multiple products. We go over 2 different methods that both are fairly useful in the real world. Break-even analysis 2, recorded around the 1st of February 2015. And the topics that I'll cover today are the definition and purpose, 3 types of costs, profit calculation, break-even calculation, break-even for a single product, then break-even for multiple products, and finally just a very brief mention of startup costs. The definition of break-even is the point at which profit equals 0, or revenue equals expenses, or there's no gain and no loss, whichever one of those is your favorite. The purpose of break-even analysis is to determine if this is a viable business. It's a go, no-go decision on whether we should pursue this as a business, or maybe it just qualifies as a hobby. The break-even determines how many items we'd have to make and sell to break even, and the market research follow-up will then determine, can we actually sell that many in the marketplace? Fixed costs, variable costs, and startup costs. Fixed costs are the ones that do not change with the number of items we're producing and selling. Monthly expenses, rent, salaries, things that don't vary with the number we produce and sell. We're going to be stuck with those monthly costs regardless. Variable costs vary with the production volume. So the material that goes into a product is a variable cost. The labor that goes into them is probably a variable cost. Startup costs are those one-time costs when we're starting a venture. Registrations, buying a building, registering with the government, certification so that we are indeed can prove we're qualified to do business. Single profit, single product, profit equation. Product is equal to the quantity times the margin minus the fixed cost. It does assume a single product, sell all you make, nothing goes into inventory, nothing comes out of inventory, and it does ignore startup costs. Margin can be calculated as selling price minus variable costs. It's also called unit profit, unit markup, probably a couple other names. And do note that we have the variable costs and the fixed costs, but no startup costs here. If we have multiple products, we just sum the quantities and the margins, subtract the fixed costs, and the only assumption we've discarded is a single product. The break-even derivation, and this is for total math geeks only. If profit is equal to quantity times margin minus fixed costs, and we set that equal to 0, it's now the break-even quantity times margin minus fixed costs equals 0. Move the fixed costs over to the other side of the equation, and then divide the fixed cost by the margin, and we have the break-even quantity. Break-even revenue, simply multiply the break-even quantity by the selling price. A quick quiz. How does one calculate the break-even profit? By this time, you're probably saying, what a stupid question. By definition, break-even profit is zero. Hopefully you caught on to that one. One can also incorporate the owner's draw and commissions in the basic break-even formula. If we have an owner draw where the owner says, hey, I not only want to break even, I want to pull out a certain amount of money each month, we just add that to the fixed costs. If we need to take commissions into account, those will simply be subtracted from the margin. Putting them both together, add draw to fixed costs and subtract commission from margin. Notice that both of these items increase the break-even quantity we will have to cover. If we have multiple products with identical margins, the initial break-even quantity oversimplified formula still works. And it doesn't matter what the selling price and variable costs are, because what we really want is the margin. So they can differ all over the place as long as the margin is constant. The break-even quantity derived this way is for the sum of all production and sales, not individually. And of course it's totally unrealistic, because hardly ever would the prices be set this way. They're going to be either set by a cost plus method of adding a percentage or a dollar amount to the costs, or it's going to be market based. If we have multiple products and we have some idea of the proportions, we can do a little bit better than the general model. For instance, a food truck selling sandwiches, fries, and drinks, after the food truck vendor has been in operation for a few months, they probably have a pretty good idea of what their proportion of each of those items that are being sold. So the break-even formula still applies, but now we need to modify the margin value. We do that by multiplying the individual margins by expected sales quantity proportions, sum them, divide the fixed costs by the adjusted margin value, multiply the total break-even quantity by the proportions, and we've got the break-even quantities. Here's an example. Monthly fixed costs, $2,700. We have 3 products. Half of what we sell will have a $3 margin, 30% $5 margin, and 20% $7 margin. The effective margin that we'll use to jam into the formula is 0.5 times $3, 0.3 times $5, and 0.2 times $7, which equals $4.40. The total break-even quantity, 2,700 divided by 440, is 614. Use the above proportions to multiply by the total break-even quantity to get the individual break-even quantities. And just as a sanity check at the end, sum the individual break-even quantities to make sure they come out to the total. I like to use Excel spreadsheets, and this is that same solution, only in an Excel spreadsheet version. An exercise for you. Monthly cost $3,500. 3 products, proportions 45%, 30%, and 25%, with respective margins of $4, $6, and $8. I'm going to show the solution, so if you don't want to see it, you better pause the video. Otherwise, here it comes. Effective margin is $5.60. Total break-even quantity, 625, and the individual break-even quantities, 281, 188, 156, and it's always a relief to see that they add to the total break-even quantity. Here is an Excel spreadsheet version of that solution, and it comes out the same, not surprisingly. A general model, now we've got different margins, unknown proportions. The basic break-even formula still applies, so we don't really use it. Set up an Excel spreadsheet, enter either the selling prices and the variable costs or the margins, enter the fixed costs, and then manipulate the quantities until you reach a zero profit point or a otherwise defined profit point if the owner would like a monthly draw. Here is what the general model looks like. Number of products, a margin, and manipulate the quantity column until that profit goes to zero or some other defined value. Quantity times margin is revenue. Again, 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 again. Sum the revenues, compare them to fixed costs. So far, I haven't been doing that well. I've got to add quite a few quantities. Here's an example. Monthly fixed costs $4,300, 5 profit margins. Now I manipulate the quantities till the fixed costs are covered. And I did better this time. I actually got to where I'm just losing 50 cents a month. Now, why do I include the selling price and variable costs since I've just been using the margin? Because maybe you want to manipulate the selling price and variable costs. Certainly if you increase the selling price, the quantities needed will go down. And if you decrease the selling price, the quantities will go up. So once again, this may have to partner with marketing research to see what's feasible in the market. Notice my solution is a solution, not the solution. Here's an exercise for you. Monthly fixed costs $1,500, margins 50, 75, $1.25, $1.75, $2.50. Go ahead and set this up in an Excel spreadsheet if you wish. If you don't want to see the answer, better pause the video because here it comes. And I got to $12.50 profit. I think that's probably close enough. Keep in mind, these are all estimates and hopes and wishes and guesses, so there's no real value in going to a lot of trouble to get it actually equal to profit equal to zero. Brief mention of startup costs. We haven't been using them. For long-term decision making, they may be irrelevant. It is a sunk cost, so if you're still in the decision phase, it they may be relevant. If you've already sunk the costs, well, just go on from here. In the short term, it may be useful to include those startup costs to ensure that you're being explicit with them. Certainly if you have 2 years of loan payments to make as a result of your startup costs, it makes sense to include those. The startup costs are covered a little bit better in my break-even analysis 1 video, also in YouTube. That's it for my break-even analysis 2 video. I hope it helped. If you're not already tired of hearing about break-even, and if you haven't already, you might want to check out break-even analysis 1. Questions, comments, send me an email with your class ID in the subject line if you're taking a class.